cool. You guys are all cool with recording? It's too late now, so. All right, cool. So, but basically, like I was saying, data scientist, database, is a way to basically connect to the database and get a lot of information. So you'll see SQL go around a lot of different ways. And there's other ways you can keep this data. For example, there's things like NoSQL, things like Hadoop and stuff like that. So just be aware that it's not the only way, but it's a very common way, and you'll see it again and again. So let me ask you guys. So I know not everyone started section 5, but I know some people have had experience to SQL. So does anyone have an idea why we might use SQL compared to anything else? Any guesses? And you could just say, I don't know, maybe it's because of this reason.
Because we're query out of a database, so we need to get the data first using SQL.
Yeah, it's gathering the data. So like if the company has data, for example, and they have a database and they use a SQL server, well, you're going to use SQL to get that data. That's probably the easiest and quickest way for you to get that if they have that access. Okay. Anyone else got an idea why you might use SQL?
Server can store a lot of data compared to like an Excel spreadsheet.
That's right. Yeah, good. There's a good comparison is Excel spreadsheets, right? You could have a CSV file or an Excel spreadsheet. But that is an actual file that you have to take and hold on your computer and deal with, versus like you have something in the server, you can query. We'll learn about query is, but basically you can ask for the server, say, hey, give me this kind of data, and it'll give you that data from the server. So SQL is really a way to communicate your needs, essentially. And once you say, okay, well, give me this data, then you get that data, and then you can deal with stuff. So that kind of comes down to a little bit of like something with speed. So SQL is actually pretty fast in a lot of ways of how you can query things. So for example, one way you could do that, like your data, is you could get all of the data, right? I mean, theoretically, you could get all the data from a company, take that, and then put into your pandas or whatever you want, and then sort through it. But that might take a long time, right? So SQL can actually speed that up significantly. Say, well, okay, I don't want all the data. I only want this kind of data with this specific kind of parameters, and get that part. And of course, there's ways you can merge that with, we'll see later on, with pandas, and basically figure out what's the most efficient way. Sometimes it might make sense for you to just say, all right, SQL, just give me all the data you have. I'll take that, and then you sort it with pandas. And other times it might make sense, well, let me take more time on the SQL query, which might take, might not be the most efficient, but you have that data, you don't have to carry it through the internet or wherever you're grabbing it from. So it all depends on situations. So SQL is kind of like a really good, I like to say it's like the intermediary between like what you would do as a data analyst, like where you might using SQL a lot, versus data scientists, you will tend to use more pandas and Python, kind of like analyzing that data. So it's a good way to go in between those parts. Okay. So I didn't really talk about what exactly is SQL. So does anyone who's had experience, especially, how would you explain SQL?
I mean, it's like everyone else said, it's just the data warehouse for things, and I mean, it uses its own indexes depending on how the database is engineered or structured, so that makes it faster, and it's generally more organized and easier to manage than a bunch of text files or CSVs. I run into that a lot at work.
Mm-hmm. Yeah, that's perfect. I mean, that's exactly right. And that's very computer science-y kind of thing too. It's like the idea of SQL is that you don't have to deal with how the data is managed. You don't have to have a bunch of, CSV files and then reading those in. Basically, there's some other server that's hopefully optimized for that, and you can pull that information through. Okay. And then for those people who, obviously when I'm talking about SQL and stuff like that, SQL is organized in something with like tables. It's a relational database, tables. And if you look at a table, you'd probably say that looks like an Excel sheet. Or if you're, data scientist from Pandas, you're like, oh, that is a data frame. So it has a very similar structure to each other. In fact, I think a couple people mentioned about merging data frames in the section, I think it's section 3 or section 4, I can't remember now, but combining data frames together. And actually a lot of that syntax comes from SQL. And that's because really that's the first part of data. It's like a lot of people started with data, with SQL. Okay. And I think I see Olivia now here too. Hey, Olivia. So, so kind of a basis, I'm trying to give you guys some kind of context of why SQL might be important before we start digging into it. Because when I first learned SQL, I was like, I don't understand why we can't just do it all with pandas or something like that. And one thing, when I worked for a credit union, they basically everything was doing through a SQL database and everything like that. In order to interact with the database at all, getting all that information, I had to use something called DB2, which is like, again, is like a server. You don't really have to really know exactly what it is. Just know that it's pretty much you use SQL to communicate with that server and get that data. And then once I had that data, I'm like, cool, I can take that, put it into pandas, and then do all the cool stuff with it. All right. So this right here, I'm going to share with you guys. And bear with me, I'm still getting used to how to use Zoom properly. So I'm going to share my screen with you guys. Okay. So first I want to show you guys this. So this, for example, is a schema, and this is showing basically the aspects in the table. So you can imagine each of these, like, what's it called? Each of these tables right here, and that's really what these are essentially like their own little Excel sheet, okay? And so you can see, for example, this has product lines, this has employees, then we have offices. And so the idea here is that you have the data organized into these tables, essentially like I think of them like little, maybe not little, but like Excel sheets, right? Or CSVs. And they might, for example, these are the columns. You have office code, city, phone, address line 2. But the whole point of all of this information is that it relates to offices, okay? And so if you guys realize on the curriculum, we actually talk about it as saying not just it being SQL, but a relational database. And in relation, like I always like to take these words apart and say, okay, relational database. So relational meaning that it's related to each other. So your database is basically built of these tables that are connected together. And you can actually see these kind of lines right here. That's what they're trying to show. It's like, oh, employees and customers might be connected in some way. Or for example, product lines and products, or offices and employees. Like those might have some kind of relation with each other. And that's how you can kind of like connect these different tables together to form this huge entity. Now, just know that you don't necessarily have to have these connections, just like employees and products doesn't seem to have a direct connection. But you can kind of see it's almost like a little maze sometimes, trying to figure out how this would all connect together. And we'll talk about that, exactly what's going on. But let's see here, clear this off. Okay, so, excuse me. So I kind of said like how we can connect these together. And one thing is that, like I said, all of these tables, that's what this is a table, have different columns, right? Okay, and that's what all of these things are. And then you'll notice, for example, is that there's a little star right here. Okay, and that little star basically usually represents on a thing like this, which is called a schema, is representing its primary key, basically saying what is the thing that makes it this specific table. Like what is the thing that identifies for this specific table? Just know that primary keys will need to be unique to within that table. So if you have, for example, a primary key for a lot of like, financial institutions, can anyone take a guess what that primary key might be for a person? Any guesses?
Maybe like the account number for that particular person.
Account number, so maybe account number for that, which they definitely use.
Social security number.
Social security, that's a big one, which has their own little like issues with like why that might be a big deal. But social security is usually used for a person because basically you can guarantee no person should have a different social security number. So if you have a social security number, you know who that person is essentially, right? Let me ask you guys, would last name be a good identifier for a person?
Not at all.
Yeah, immediately like, no, can't at all. And one of the reasons why is like, oh, well, if you have family members, well, of course, then you don't have necessarily a unique thing. And of course, I don't think the curriculum talks about this, but you can actually use multiple fields, multiple columns to create one unique key. Now, that actually tends not to be very great practice. You could do it. There's nothing wrong with that necessarily. But from like a practice field, it just makes it more complicated. So for example, you could technically take all of the elements, all the fields in here and make that essentially one big primary key. but that's not super useful in a lot of ways, again, because it's super big. But one thing is you can find a very specific thing like a social security number, or in this case, you can see like an employee number. There's also something special called like a serial. And those people who have done SQL, has anyone heard of serial before? And not serial you eat, but S, okay. So serial basically, it's basically an ID, and a serial will actually increase. And so you can guarantee basically as you insert a new element, like a new field, not field, sorry, let's say you add a new person into your employees thing, the ID would increase by 1 or some number, and that will be a serial. So you'll usually see this a lot used as a primary key, and you'll see it as ID or serial or something along those lines. So these are things that you should be like at least familiar as a data scientist, because you'll probably see in other companies, especially if you're asking for, hey, I would like some data from you guys, and they're willing to give it to you. But if you don't know what their structure is, it'd be really important to understand how to navigate through that. Okay, so that's kind of a quick kind of going through the idea of what a schema is and how databases are really set up. Any questions so far? Any comments that you guys like to add in? Okay. Thumbs up if you're feeling pretty good with it. Maybe sideways, down. Okay, cool. Yeah, good. So good. Hopefully it felt pretty elementary from what I explained. So let's go back to my mouse. So again, this is the actual database itself, but we haven't really talked about what SQL is, right? So SQL are basically, it's just essentially like a programming language. And so I'm going to kind of go back a little bit, is that Eli actually created, as you guys saw before, this resource list. And so, for example, we have things where it talks about aggregate functions. There's a cheat sheet for some basic, not basic, but like some things that you can use for SQL. And you'll notice this word queries. And what we mean by a SQL query, if you imagine this is kind of like the database, a query is basically looking at that database by asking, saying, hey, give me some information. You're asking a question to the database. All right, here's my question. Give me some information. So all of these, for example, oh, someone say something?
Oh, sorry, talking to myself.
Okay. So you have, what's it called? Like these, for example, the select star from country. This is a query. And basically you're asking the database saying, hey, I want to select some information. In this case, we'll talk about what the star means, but basically select everything from this table, country. So basically you can ask questions to the database and get things back. And we can actually get very, very complicated. So for example, I think we have this cheat sheet right here. You can see there's a lot of different ways we can ask the database, select column from blah, blah, blah. We can use where statements. We can use grouping by. I'm not going to go through all of this stuff just because the curriculum does have it. And honestly, it's probably worth more of your time to go through it yourself, see what works versus me showing you one time. But we will talk about some of the different commands you can do. So any questions on this so far? I know I haven't really explained very much, just kind of showed you that this does exist. Okay. Cool. So I'm gonna jump into some, what's it called? Some code right here. And this is actually a little bit, we're actually combining Python directly with SQL. So you actually see right here, this stuff right here should look kind of in a sense familiar in that like, oh, this is some kind of Pythonish kind of code. And then this stuff right here, you'll notice this is all a string, right? And this is probably not as familiar because it's just not Python. But basically all you have to know is that this stuff right inside here is your SQL commands. And basically you would connect to a database and you say, hey, all right, database, I have a question for you. Give me some data, all right? And depending on the nature of how the database is structured, you can actually ask that database and say, hey, like I want this information. So basic parts that kind of break down into SQL is that you have a select statement. So you say, hey, I want this information. I want it from this table. Okay, this is probably not the best example. And then you might also give it some conditions. For example, this where, for example. And so you'll usually see SQL actually written out like this very commonly, like one full line. I actually prefer not to write it that way. Now everyone has their own kind of like idea of what they like and what they don't like. But when I write out my code for SQL at least, is that I'll actually separate out the select statement. So for example, I'll have select, and then I'll have from, and then I'll have other things, for example, we'll talk about is like where. But like at the very basic stuff, this is a single query that we can have. So I kind of walk this through. But one thing to note too, is that compared to Python, if you guys haven't noticed already, Python's very finicky with its formatting. So if you add some extra spaces, right, or like an extra thing like this, if I add some extra space, Python's gonna get really angry at you, right? SQL is very forgiving. SQL basically doesn't care about white space. You can put as much, spaces in between. So that's why it's actually very common to see really differently created SQL commands, or I should say queries. Okay. So
Victor,
yeah.
do you mind zoom in a little bit?
Oh yeah, is it too small for you guys to see? Is that better?
Yeah, it is better.
Okay, cool. I had it really large, so that probably helps a lot. Okay, cool. So, excuse me. Good, where was I? Okay, so again, don't worry about too much about this cur execute part. That's for me just setting up. I'll share this out too. And you can just see kind of like, I commented this out so I don't accidentally run it, but you can see we're using a library called SQLite 3. There's other different libraries you could possibly use. This is the one that the curriculum uses, so I'm gonna stick with it. But kind of going through is like, if I started over from like, all right, I wanna connect to this database. I get my library, SQLite 3. I create a connection with SQLite3.connect. And then this right here, planets.db, is the name of the database. In this case, I'm actually assuming I have a local database, that it's like the database is right there on my machine, or if I'm connecting on a server, it's in that server. But that might not necessarily be true. You might have some, for example, something in the cloud or something along those lines. So this might actually be a URL at times. So this all depends on the situation. Okay, and this part is probably, in my opinion, a little confusing when you first see it. And so I'll name this variable called cur, which is basically short for cursor. I just didn't want to write cursor. And this is equal to the connection, which we created over here. And we're basically saying, get the cursor for this connection. And this basically is just saying like, hey, here's our spot in the connection. So we know we can basically write a whole bunch of commands and then send them out all at once. And one of the reasons why you can do that is because sometimes SQL, depending on how big the database is or how complicated your query is, it can take a very long time. Sometimes, depending on how you've written your query, it can take like, maybe 5 minutes to even like 30 minutes if you're really bad at writing SQL or you're getting a lot of data. And that's why we have this part right here. But that's what you can kind of see. And of course, I got pandas and NumPy. Don't worry about too much of this. You'll see this in the curriculum. This is basically to like create tables. So you'll actually notice that I can create a new table in there. I can insert information into that table, just like you can like input stuff into an Excel spreadsheet. I won't go into this because the curriculum does go over quite a bit. And I think you don't need to see me typing a whole bunch of stuff and just running it. So just know that that's how you can insert data into the database itself. Okay. So any questions so far? Cool. Okay. I feel like I keep kind of going back to saying, all right, here is your, what's it called? Like, here's your database. But the important part is that we want to actually ask some questions for the database. So this one right here, you don't have to worry about too much about this, but basically this is asking something a little more meta information, where basically I want to see what tables there are. So I had that connection to planets.db, just know that I have connected to a database. And so when I run this now, I can actually see what tables there are. So this says select the name from basically this special table where the type is a table. So basically I'm just trying to figure out what the tables are. This is just something useful because if you don't know what the database is, you can check out, hey, what tables are available. Sometimes there's only 2 tables like this. Most likely you'll have something with many, many tables, depending on what the situation is, okay? So going here is a more typical query we'll have. And note that this is all the Python code right here. This cur.execute, and this is the .fetch all. And the reason why I do .fetch all is because if I take this out, you actually see that it gives me an object, and that doesn't really give us information. So we actually have a function built into SQLite 3 that allows us to actually get this information to see what this is. And you'll notice that I just made up some exoplanet stuff here. So, and you'll notice that there's like these numbers here, this name right here, it looks like a color, another number, some other number with decimal, and of course another number. And so you can think of each of these lines right here, each of these what we call tuples, right? Each of these are like a row within a spreadsheet. And you can think of each of this part, these vertical columns are just columns in a spreadsheet. Okay, so the idea here is that whatever this green is, blue, yellow, red, that's all from the same column. Same thing for like, you know, these names or for these numbers right here. They're related to each other. Now, unfortunately, SQLite 3 doesn't make it really obvious what these things are right away. So we can actually do something, excuse me, we can actually use the cursor to get the description of what we just asked for. So if I actually run this now, I'll actually see, okay, this goes in order from left to right, ID, that's what this is, the name, which is this, color, green, number of moons, 4, mass, 3.21, and rings, 1. So that's the way you can kind of see what those columns are, all right? Cool. So we have some information on here, and I have to tell you, how do I know how to do that, right? So what this is right here is that SQL query. And again, you always have a select and a from. And basically this is just saying from this table or tables, you'll see, I can select information. So this star is kind of a wild card. It says, get all the information from this table or whatever your from statement says, okay? So for example, I actually have another table in here, planets, like we saw up here. So I can actually select everything from planets. And I can see I have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto, right? Which I don't know why Pluto's in there. But anyway, you have all this information right here. And of course, if I print out now the description from this little guy, which hopefully you guys feeling a little better with this comprehensions. Basically, it's just going through each description from here and just printing out the first one. And you can see it's just the ID, name, color, number of moons, mass, and rings. So kind of the same thing as the exoplanets. Okay, now let's say, for example, it's like, well, I don't want everything. I just want the names. What are the names of the planets, right? Well, I can just say, okay, well, let me just ask for the name, select name from the planets table. And if I run that now, we'll actually see, we'll get a list of the tuple right here, Mercury, Venus, Earth, and so on and so forth, right? So, excuse me, we can select one thing, but what if we wanted to select multiple parts? Well, let's say I wanted the name and let's say, I don't know, how the mass. So I can actually do name, comma, mass, and I can see, hey, cool. I can see Mercury, Venus, Earth, and also what is the mass. And I think in this case, it's supposed to be how heavy, like one mass is essentially one Earth mass. So obviously Venus is smaller, Mercury is much smaller. Mars is not 0.11, but whatever. It's a big database. So, or maybe someone made a mistake in the database. But that's how we can get multiple parts, okay? Now, we can actually do it from multiple tables too. So if I do now, exoplanets, if I spell right, we have our planets, exoplanets. If I run this now, you actually see it's like, oh, wait, what's going on? And you'll see that it says it's giving me an error called ambiguous column name. And that's because both planets and exoplanets have the same names in some of their columns. In this case, every column is exactly the same. Not every table in a database will have the same columns, but if you have any conflict, you'll have issue. Basically, SQL or the server doesn't know what to do. So what we can do is say, okay, well, I want the name of just the planets. Okay, so we can say, okay, well, planets. Name. Oops, of course this won't work either. You can actually see I get this part. And you might say, wait a second, well, what's going on? Why am I getting a bunch of repeats on Mercury, Venus, Earth? You know, you'll actually see that it's repeated 4 times. And that's because basically it's going through every element in here and getting all that, getting the planet's name. So if we have 4 exoplanets, it's going to repeat 4 times for each exoplanet. So if you did this, basically it'd be 4 times however many planets are in here, in this case 9. So it'd be 36 different elements in here. So that's what's going on. So this is something like, again, like I'm not going to go into full detail of everything that you can do with SQL because there's so much you can do with SQL. And again, the curriculum goes into better detail and more precise. And I think it's a good thing to kind of check out. But just know that that's why I need to put this planets in front here. So it's good practice, actually, even if you're just using one table, it's just to put that planets.name, basically the table name, and then the field name or the column name. And that will give you the same information. Okay. So any questions on this so far? Okay. Thumbs up if you're feeling pretty good, at least like, all right, I think I'm getting most of this. All right. Sideways, you're just like I think I might get it. And then thumbs down, you're like, I have no clue what's going on. And don't be shy.
So I can save this fetch all object into a data frame, right?
Yeah, that's exactly right. That's actually the next part that we'll end up doing. We can actually take this information because like, you're like, cool, I have this data, Victor, but like, what am I supposed to do with it now that I have this in this list form? Remember, lists are great, but data frames are even better, right? So once we have this query, we can actually do something. So one thing I did is I like to have the actual column name so I know what's going on. This is how you can actually use Python. So for example, I defined a function right here. And so I named it SQL with columns. So you'll notice when I get the results, I don't get the column names, and I kind of want the column names, so just for my own use. So you can kind of check this out, but basically I'm getting the result. I take in a query. I basically get the result by getting fetch all, which remember won't give me the column names, but then we can do that print description, right? This guy right here. Basically I create a tuple so I can add into the list and basically take that full result. So I have the columns as one row, essentially, one item in the list, and then the rest of the results. So if I run this now, I have this cool function, and I just made it myself, right? And now I can do this guy right here, and I can actually get the same idea with having the results, but then I also get the columns up here. So this is how I'm trying to show you, is like, oh, you can change how you want to get information from SQL. Oh, some other question? No? Okay, cool. So I just kind of made this real quickly, but then what we can do now is what Bonnie was asking is like, hey, what if we want to actually put it into pandas, right? So right down here, I have a little more of a query, and you'll see I have to select exoplanets.name, exoplanets.color, exoplanets.number of moons from this table. Kind of a simple query, as we'll see. We can see the results right here. And we have from that special function I made, we have the name, color, number of moons for each part. But like Bonnie said, what if I wanted pandas, right? What if I want to actually do something with that data, right? So we can actually take this results, and in this case, I can pass it into my data frame. And if I do this now, I actually get like a classical data frame where I have the name, color, number of moons, and then of course, here's the ID over here, which is the index. And then we can also have the names and all the information. So if I had wanted to do this differently, so let's say, for example, I didn't do this part. I did her.execute like this. This results, let me kind of just get rid of this so we can see it real quick. So I do the fetch all. You'll see like I don't have any information here. This is actually how I think the, what's it called? The curriculum will do it. So if I save this, let's say I'll just overwrite results. So results equals results.fetchAll. You can create a database just by doing df. I'm just saving as a variable. And then we have our data frame. And then I can just pass in the data directly onto here, which are just results. And we'll see df.head. And this time we just won't have a column. So you'll see that I have all the information, it's just we don't have any column names. And by default, Pandas says, we'll keep it as 0, 1, 2. Now, if you already know what the information is, you might just say, you know what, I don't need to write this whole function that I wrote up here to get the column names. You could just say, all right, I just want to get the information, pass it through, and do my thing. If you wanted the column names directly on here, you can also do, for example, when you actually create this data frame, you can actually say, okay, columns equal. And this is just from the documentation. I suggest reading up a data frame documentation because you use it a lot. But you can say, okay, what are the column names? And I say the columns are, and remember, I did this guy right here, this description, description 0 for description and cure.description. It's kind of a mouthful. Just know that I'm getting description. You can kind of play around with it and see what it does, but I'll just kind of show it here. I can pass in this list right here, and this will actually create the column names up here. But because I'm kind of like, I don't want to keep writing this long thing, I just fold it into a function. I think the curriculum actually shows a way, one other way you could do it, where you can make a function that just returns a data frame. So you could create a function. If you're constantly getting the data, putting it into a data frame, you might as well just make a function, right? Cool. All right, so any questions on this? Any comments on it? Okay. So this is kind of like the basics of just like how you can get the data from the from a SQL database. You can use SQL right here. Usually in data science, you tend to see smaller little queries like this, like maybe like, I'm just gonna make something up, like about like 30 lines. I've probably seen like about how big it is for most data science stuff, mostly because then you can take the data and then sort it out with pandas. But I mean, I've also created SQL queries that have been literally like, I don't know. I think my largest one I ever made was like 400 lines of SQL. And to be honest, I didn't like it because it's very hard to kind of navigate through. And some people, honestly, some people have said, I prefer SQL over pandas. And I say, well, I am not you for sure. So just know that's an option that you can do. But if you are someone who likes SQL too, you can actually use SQL to query your data frame. So like you can, as if you are querying a database, you can query your own data frame using SQL. So that's an option too. And I know that shows in the curriculum. And that's a pretty cool way to do things. Cool. All right. Any questions on this guy? All right. Cool. So I kind of showed this down here, which is basically, excuse me, this is kind of some more advanced stuff with aggregation. So you'll notice we have our normal select, we have our from, then we have our extra stuff. For example, here we have group by. And group by does something called aggregation. And basically we can take the data we have, and so in this case we're doing planets, so I'm just going to put up, just to kind of show you what the planets were. Let me put in a new code base right here. If I want everything from planets, right, and I want to do any group bys, just to show you what the data is, we have this, right? But let's say I want to group by, say, hey, I want to know how many moons each, like how many planets have so many moons. So if a planet has 0 moons, how many planets have 0 moons? How many planets have 1 moon? How many planets have 2 moons, and so on, okay? So we can actually do something called a group by right here, and I'm gonna group it by number of moons. I'm taking it from the, what's it called? The table planets, and then I can do like the number of moons. So I can actually see how many moons there are. But then I have this special thing right here, this count function, okay? And this count dot, count star. And this count right here basically goes through this grouping and basically adds up everything that's in there. So for example, I have Mercury, Venus, they both have 0 moons. Number of moons, Pluto doesn't have 5, that's weird. Okay, I don't know who made the database. But basically, if I were to aggregate this, you say, okay, well that means 2 planets would have 0 moons. It looks like 1 planet would have 1 moon, and then, let's see here, 1, and so on. So if I run this now, we can actually see basically number of moons, 0. How many had 0 moons? 2 of them. And then you can see the rest of them. 1 moon, only 1 planet had 1 moon. 2 moons, 5 moons, each planet only had this many. But you can actually do groupings in this way. And so this can actually be really useful, for example, if you want to group something by, let's say, like we were talking about, like finances, for example. Let's say you're working at a bank and you want to know all the accounts one person has. Well, you can actually group all the accounts based on someone's, unique identifier. It's like their social security. And you can actually say, how many accounts do they have? And there's actually other functions too that I won't get into detail because there's so many you can do. But you can actually use this function. So I won't confuse you guys. But there's a bunch of things you can do to count this in there. Okay, to aggregate your parts from the database. Okay, so again, there's a lot of options in here. And what's kind of interesting though, again, like you could do the same stuff once you have the data. Like you could just take all this data, import it into a pandas data frame, and then process it, which has its advantages in the sense that you know what all the data is in there, and you can kind of process it like a normal, step. However, it can be sometimes beneficial to just ask the database to do it for you. Say, hey, I know what I want every single time. Here's my SQL, and maybe it's very quick in that sense. This is when it gets a little more computer science-y, where sometimes it makes sense to actually use the server to do everything versus your own side doing pandas. But again, it depends on the situation. And also, honestly, your preference. If you feel really comfortable with SQL, you could do SQL like all the time. Again, that won't be me, but you can possibly do it. Okay, cool. So any questions that you guys have from anything I showed you guys? I know it's kind of a lot, and I didn't go into super detail about it, but also there's going to be a whole lot in the curriculum that will go into further detail about how to do each part of SQL. And don't be shy if you guys have any questions, or if you felt like I didn't explain something completely and you want to know more.
I do have one question. It's not particularly with SQL, but it's with your the triple quotes. Is that what is that?
Oh yeah, that's a good question. Yeah, it's not SQL. It is Python. So for example, you guys know I can do like a whole string like this with single quotes. I can do with double quotes a whole string like this. And of course, what you just saw is this triple quotes. I can actually use 3 quotes right here, and I'll just put like something long like here. And so normally, I'm going to get rid of this. Normally, if I do these parts, it runs perfectly fine, right? But if I wanted to do like a new line like this, you'll see that Python's like, whoa, I don't like that. Like, that's not good. Basically, it's because it's breaking in the middle of here. Python's not sure if you meant to be a new line or if it's supposed to be continuing forward and stuff like that. So what triple quotes allows you to do, it's kind of a Python shortcut to say, hey, if you do want to put like some extra spaces in there, so like this, you can actually put in whatever you want. So like that. And so now if I actually try to print this, if I do print A, print B, and print C, you can actually see this is A, this is B, and you can actually see in my whole thing right here, it keeps that formatting. So again, like I like keeping things on a separate lines like SQL, because that's the way I kind of learned it, and in my mind that kind of forms better. But that was a good question. And also, in case you're wondering, you don't have to use just single quotes. You could put in, say, D equals 3 double quotes, and it would work the same exact way. Okay, cool. Answer your question, Dave?
Yeah, that's kind of what I figured it was, but I just wanted to make sure that that's what it was. Thank you.
Yeah, it's a pretty cool trick. And again, you'll find things like this in Python, and you're like, oh, cool, I didn't know I could do that. And of course, like, if you guys are wondering, you guys learned about F strings and stuff, which when I first learned about was amazing. I was like, what? You can do variables within there. You can use F strings within. You can use F strings within these triple quotes. So you can see that kind of comes out. Right. So they just work like normal strings, but they're multi-line. Okay.
I have a question.
Yeah.
So if you want to connect your code with a local database, let's say like PostgreSQL, how do you do that?
Can you say that one more time?
If you want to connect your SQL, your notebook to a local database like Access or PostgreSQL, how do you do that?
Okay, yeah, so it all depends. Because SQL, in a lot of ways, I keep saying like SQL as if it's like one single thing. SQL actually in a lot of ways can be different. Like, so if you guys don't know, you can have, for example, like DB2, you can have MySQL, you can have SQL basically through Oracle. So there's all these different kind of databases, and each one has their slight different ways to connect it. So here I have connecting through SQLite right here, which is basically like a local part, and I can use this database right here, which is basically essentially just a file, optimized hopefully. But I can connect to this part. If you want to connect to a server, you'd have to basically look at the specific library. In this case, you would look up the library for SQLite 3 and say, okay, like, I need to connect to an external server. You have to make sure you have the permissions for it from the server side, and then you possibly have to pass in like a username and password. And then depending on that server, if it uses MySQL or DB2 or whatever it's using, you'll have to pass in the right kind of, what's it called? The right kind of formatting. And so it's hard for me to say exactly how you would do it. For example, PostgreSQL will use something different. And for example, for Postgres, I've seen a lot of something called SQL Alchemy. Probably going to spell that wrong. But SQL Alchemy, I've seen a lot for PostgreSQL. Now, I don't know if that's because it's easier, or just because people who did Postgres just happen to use SQL Alchemy. It just all depends on what the situation is. So my suggestion, if it comes up, you're like, oh, I want to connect to this specific database, it's probably best to know what, look more at what the database is, where it's coming from, and then honestly doing a Google search and saying, how do I connect this? And usually that will give you a good idea. Yeah. But real quick though, since you did ask about connecting to a server, for example, like something else, and usually you have to pass in your username and password. When you guys are using GitHub, like you guys are kind of committing and pushing, be very careful not to have your username and password coded directly on here. So for example, if my password, if I have to pass it, I'm just gonna don't really think this is true, but let's say password equals, 123 or ASDA, user equals, I don't know, Victor, okay? And let's just say this is not the right way to connect it. I don't know what the proper connection is, to be perfectly honest. I'd have to look it up. But let's just say we have to connect to say, okay, it's gonna be something like my user password like this, okay? And then you might have something like, a connection port. I'm just making some numbers up, okay? So that might be the format. If you save this, this will be perfectly fine. And you might even, you might forget about this because you run this, you get the connection, do all your code further down, and then you save it and then post it to GitHub. Well, just know that your username and password's right there. So there are ways to kind of help you not do that. For example, because there's not a real good way to say, oh, how do you not hard code it directly in your notebook? There are ways you can basically create imports and basically keep it as a separate file. And so you would see something like import user, or sorry, I have this from my keys. So I create a file basically called my keys, import user and password, and then this would work right here. So that way you can just upload this file, and if someone gets, if you basically put it on GitHub or whatever, they can't see what your username and password is. So again, not something we really talk about, I think, but I think it's kind of something to be aware of, especially if you guys are working for another company. It's you don't want to put in your credentials in and say hey, Victor, did you put in your username and password online? It's oh, no. So yeah, which it's kind of surprising. It's really sad, actually. A lot of people will use GitHub and they're not super careful or not really thinking. And I guarantee there are bots that go through GitHub looking for usernames and passwords that people accidentally uploaded because they're there. So, and also know, if you do that on GitHub, we haven't talked about, has anyone done any of the GitHub thing I posted I think it was a week ago, maybe even a week and a half ago, about how to do GitHub? That one I really strongly suggest if you can, because GitHub's a really good versioning tool. But if you're doing multiple commits, and let's say you accidentally put your real password down here, and you put it in there, you commit it, and you're oh shoot, my password's on there. So you erase this, you erase this part, and then you save it, commit it again. It's still actually on GitHub, even though you won't see it right away. And that's because your commits basically keep a history of everything that's going on. So if that ever happens to you guys, I honestly would say just delete the repo offline. That's honestly, that's the quickest, fastest way. There are ways to deal with it called rebasing and basically doing branching, but to be honest, it's a pain in the butt and you don't want to do that. When it's oh wait, let me figure out how to rebase, and at the same time, people are just taking your stuff. So yeah, just be aware. Yeah, but good question. I know that you didn't ask that specifically, but I thought I had to bring that up. Cool. All right, cool. Sweet. So any other questions? Any other things you guys would like to know about right now? it sounds like most people haven't looked at section 5 yet. So obviously, as you guys get more questions or like, wait, I don't understand this, of course, ask questions on Slack, ask each other, ask me. Of course, Google is a great friend. He or she does not judge you too much. So you can always ask him whatever question you want. Yeah, cool. All right. So again, any questions, comments, concerns?
That was a great lesson, Victor. Thank you very much.
Oh, thanks.
Yeah, thank you very much. It's great.
Oh, thanks. You see, Eli left, so he didn't get to hear that. So now you're gonna have to tell him or say, hey, Victor had an amazing lesson. We're glad you're gone. I'm just kidding.
It's okay. It's recorded. It's recorded. You can edit just me saying that and just rub it in.
Ooh, maybe I should just cut that out then. I have to figure out how to stop the recording. How do I do that? I'll do this. All right. Eli, if you heard that, it didn't happen. Stop the